This is the 2017 F equals MA exam, and this is problem number 2. So we're given a large box with some mass m, and within this box we have a tiny spring connected to another mass inside. So initially, when our box is held rest, it is stationary. It has an angular frequency of omega. But now the box is dropped to fall freely under gravity. We're asked to find how will the angular frequency change. So first thing to recognize is that although initially only the small m will be oscillating back and forth when it's stationary, with the large m, idealized like a point mass here, which is namely the ceiling of our box will remain stationary. Once it begins to fall, we find that this is not the case, and rather that the only thing that does remain stationary and that does undergo true free fall will be our center of mass. And while our center of mass is falling freely under the influence of gravity, we have oscillation here and we have oscillation here. So we want to find the center of mass. So we have our large m and we have our small m, and here is our center of mass, which we'll say is our 0 point. Let this distance be x. Let the distance from the center of mass to small m be L minus x, and so we have the total length of our spring is L. So we have at the center of mass, we want to consider the total mass, which is just large m plus small m, times its position, which is 0 in this case, and this has to equal to the weighted average positions from mass of these two masses. So we have negative x, since it's to the left of our center of mass, times large m plus L minus x, positive since it's to the right, times small m. Now the left just becomes 0, so we have the negative mx plus ml minus mx is equal to 0. And since we want to solve for what x might be, then we can move both these to the left side to get that large m plus small m times x is equal to m times L, and thus we find that x is just equal to m times L over large m plus small m. And similarly, if we can also find L minus x, where L minus x is just going to be L minus ml over m plus m, or in other words, L times the denominator minus the denominator here, minus ml over large m plus small m, and we will cancel out this term right here to get large m times L over large m plus small m. And so we find our distances of our two objects from the center of mass.